Today we will learn about electricity. So for this, let's start with understanding Ohm's law. What Ohm's law is? Ohm's law states that the current flowing through a conductor is directly proportional to the voltage dropped across it, provided all physical conditions such as temperature remain constant. So its mathematical form can be the following. So this means that the potential difference which drops across the conductor must be directly proportional to the current flowing through the conductor. So this equation we can write in the equality form. For example, that this proportionality sign, it changes into equality. Then we need a constant of proportionality, which will be R here. Then I is the current. What R is? This R is the resistance of the conductor. So this means that this R for the Ohm's law is a constant resistance. The potential difference is equal to the product of resistance and the current. So for more detailed understanding, let's consider that we do have a conductor, and this conductor is like this. It is a resistor of the resistance R, and it is connected with a switch in the circuit, and this switch is connected with the battery, and this battery is a DC battery with a positive terminal and a negative terminal. Then this battery is connected over here with an ammeter, and then back to the conductor. This conductor is connected with a voltmeter, and this voltmeter is in parallel to this resistor. So now first let me explain you this circuit little more. So what is going on here, that we have a source of current, and this is our battery that would have a potential difference V. And in this circuit, what we have an ammeter, and this ammeter is connected in series with our resistor, that what we need to investigate. And this ammeter, it must always be in series, and its own resistance must be pretty small, because otherwise it will restrict your current flow through the circuit. And on the other hand, the voltmeter, which measures the potential difference across the conductor, that must be parallel to the resistor, because it actually needs to measure the potential difference across the conductor. So it will be parallel. We're connected at two different points. So the resistance of the voltmeter must be very large, because it must restrict the current to flow through itself. So all the current must go through the conductor, that what we need to investigate. And then we have a switch here. When we will close the switch, then current will start to flow through this circuit. But we can actually also put another thing in this circuit, that can be a variable resistor. So this resistor, you can change its resistance by actually by tuning its knob. So this is actually a variable resistor. So meaning a resistor that can have a different resistance values. So by changing the resistance of variable resistor, you can actually control the current flowing through this circuit. So now let's try to understand these three concepts: the potential difference, resistance, and current. Let's start with the current. What current is? Let's say that we have connected this switch. Now this switch is on. Now the current will flow through this circuit from positive terminal of the battery towards the negative terminal of the battery. So here current will pass through this resistor. It will not go through the voltmeter because voltmeter's resistance is very, very large. So then this current can very easily pass through ammeter because the resistance of the ammeter is pretty small. So now our circuit is complete. So it is a closed loop. So this current is continuously flowing through this circuit. So what this current is? The current is in fact the rate of flow of charge. So what current is? A rate of flow of charge. So mathematically, we can write it that our current is the change in the charge in the interval delta t. And if this delta t approaches to 0, then we can actually say that we can write it in the form of a first order derivative of the charge. So delta q over delta t. So the units of current are charge over time, meaning coulombs over second, which is amperes. So now if you look at this diagram, we see that the current is flowing from positive towards negative, which is actually according to this equation. We know that in metallic conductors, what mainly happens that this current is because of the flow of electrons, and these electrons are flowing from a negative terminal towards the positive terminal. And electrons have a negative charge. So in that case, our current definition will change into negative change in current within the interval of time delta t. So this negative sign will actually tells us that this is electronic current. So it means that direction of the flow of current conventionally, according to this mathematical equation with the positive sign, that goes from positive terminal towards the negative terminal. Now we can go to understand that what is the meaning of resistance. So the resistance is actually, you can say, it is the opposition. This is the opposition in the flow of current. So as much opposition in the flow of current, as much current will pass. So this actually the resistance, we, for example, if we consider that we do have a conductor and this conductor is like a conducting wire, so it has this circular shape. So we can say that it has the cross-sectional area, this wire A, and the length of this wire is a capital L. So now the resistance of this conductor, that will be equal to resistivity times length of the conductor divided by its cross-sectional area. So what this rho is resistivity. Rho is resistivity. What resistivity is? This resistivity is a material's property. So it is constant when the temperature is constant, and it changes with the change in temperature. So the resistance would change with the change in temperature. So that is why the Ohm's law must be valid when the temperature is constant. Otherwise, resistance would change. And you can see in the definition of the Ohm's law that this resistor is a constant of proportionality. So until your resistor keeps its resistance, then Ohm's law is valid. Otherwise, Ohm's law is not valid. And now we can go to understand that what is the meaning of this V. So before going to the potential difference, the units of a resistor. The units of a resistor are ohm, and this is the symbol for ohm. Now, the potential difference. The potential difference. What potential difference? From the name, it is clear that this is actually the difference of potential between 2 points. For example, the potential difference across this resistor, so that will be between these 2 points. The potential difference of this battery means that this is the potential difference between a point which is at a higher potential and this one is which is at the lower potential. So potential difference between the higher potential point and the lower potential point. The units of this potential difference are volts. Volts. So what is the definition of the potential difference? So potential difference actually it tells us the energy in joules per unit charge. So this means that for an example that we have a battery of 1.5 volts, which is an example of a dry cell that we usually buy in the market. So this actually tells us that that dry cell can provide 1.5 joules to each coulomb of a charge to flow through the circuit. So that is the definition of the potential difference. So here, what we did, we understood the concept of the Ohm's law and then the definitions of potential difference, resistance, and current. Ohm's law, in fact, provides the relation between potential difference, resistance, and current. So now let's move ahead. Now, after understanding the concept of Ohm's law, let's try to understand current voltage characteristics of different elements. First of all, we do have a conductor, and this is actually the resistor. It is not a simple wire. It is like our resistor R. And we consider that this resistor, when the temperature is constant, keeps its resistance. So now, if you will investigate its resistance, meaning that you measure the current through this conductor and the voltage drop across this conductor, you will have a following relation. Let's say we do have here current voltage these axes. So voltage is along the y-axis and current is along the x-axis. So now what will happen that you would observe that for this a normal conductor, you will observe a straight line behavior of this conductor. So what is going on that if this behavior is a straight line, so it means that this current and voltage, they have 1-to-1 correlation. So it means actually we have voltage is equal to resistance times current. So this relation actually validates or holds on this graph. So here you can see that this potential difference is y-axis, current is x-axis. So our equation for the straight line y is equal to mx plus c will explain this graph. So in this graph, that the c is the y-intercept, which is 0, x is the current, and this y is the voltage potential difference. So now this means that this m, if we compare these two equations, that m, which is gradient of this graph, that is actually our this resistance. That is resistance. So now you can see that if you have a graph where the potential difference, remember this very carefully, that this potential difference must be along the y-axis and current along the x-axis. So in that case, the gradient of your curve actually gives us the resistance value of the conductor, and you can see that the gradient is constant. So then this resistor, we can also call it that is a ohmic resistor. That is ohmic resistor. And you can investigate the curves using the mathematics. Like you can apply the mathematics and you can understand that what the gradient is representing. But on the other hand, that if, for example, we say that we have a graph where x-axis is the potential difference and y-axis is current. So then you can see, if you will compare your this straight line equation, then you would see that our y is a current this time and gradient is m and x is the potential difference. So now this actually reveals that the potential, this sorry, gradient must be equal to 1 over resistance, 1 over resistance. So be very careful and keep an eye that what is along the x-axis and what is along the y-axis. But according to the Ohm's law, better to put the potential difference along the y-axis, then this Ohm's law will be actually directly, you can say, understandable. And now we consider that, for example, we have a resistive wire, and this resistive wire we have connected in the circuit that we actually had in our on our previous slide. So now we can try to understand the behavior of this kind of conductor. You can even consider that, for example, that it is a heater or a filament or a resistor wire. So now what will happen that you would see that, for example, our voltage is along the y-axis and current is along the x-axis. So now what will happen that when you will apply, you will try to flow the current through the conductor. So the voltage will drop across the conductor. So then the increase in the current will express what the increase in the voltage will, this the voltage that drops across this wire that will be increasing. So the same behavior will happen other way around. So now, if for an example, we say that y-axis is the potential difference and sorry, y-axis is the current and x-axis is the voltage, then you will see the behavior like this. So the both actually the graphs are same, but we just flipped the axes. So you can say that red and white, they are inverse to each other. Now, here, let's try to understand what is happening. So we can consider this red curve. So what we are doing here, we are increasing the current and the potential difference across the conductor is also increasing. So it is a little bit, you can say, the linear at the lower current value. And then it is turning into non-linear behavior. Non-linear behavior means that what is happening that we are trying to increase the current, but the current is not increasing, voltage is increasing only. Or means that this actually the correlation is not actually direct correlation. So the voltage is increasing more compared to the increase in the current. Now you can understand that it means the current is suppressing. If current is suppressing, it means that opposition in the flow of current is increasing. If the opposition in the flow of current is increasing, then what is increasing? It means resistance is increasing. What is increasing? Resistance is increasing. So if resistance is increasing, then can we apply Ohm's law here? No, because for Ohm's law, resistance must remain constant. And then here you could also understand that if current is actually facing more and more resistance, it means that there will be more and more dissipation of the heat energy. So this behavior is also of a filament or a heater or a normal resistive wire. So this one is non-ohmic. So Ohm's law cannot be applied on this kind of a behavior that are non-linear because the resistance is not constant over there. So this is a simple understanding of current voltage characteristics of different elements. So we took the examples of an ohmic resistor and a filament. So then we can actually also with this understanding, with this concept, we can also understand the current voltage characteristics of other elements. Okay, so now we can move on to understand the concept of drift velocity. To understand the concept of drift velocity, let's first see that the picture of a metallic conducting wire. So in a metallic conducting wire, what we mainly have the positive ions and that are fixed at their fixed positions. So they can only oscillate, or you can say vibrate, according to their thermal energy. And these vibrating ions, they are in a sea of free electrons. You can also call them that these are delocalized electrons. And so they are free to move. So they are in a conduction band, so they can move within the conductor. So what will happen that when they will move within the conductor, so they can have the interaction with the ions. So they can continuously collide with these ions. So it means that their motion through the conductor is like a drifted motion. So then the velocity of these electrons are the charge carriers within the conductor. We can say that is our drift velocity. How we can understand or formulate the drift velocity? Let's consider that a current I is passing through this conductor when we apply some voltage across this conducting wire. So then we know that the current is equal to the charge divided by the time. So you can actually write in a more proper way that the change in the charge divided by the interval of the time in which this change in the charge is happening, meaning that how much charge actually passed per time. So now we can calculate this charge. Let's consider that this our wire, it has a cross-sectional area A and the length is capital L. The length of the wire is, let's say, capital L. And then what is happening that the charge particles that are flowing through this, you can say the conductor, that actually can be, you can say the, let's first go to calculate the charge, that how much charge is going there. We have a charge of one charge is E, which is quantized value of the charge. And now this is actually flowing through this conductor, the total number of these charge particles, N. What this N is, that we call it that this N is a number density. This is a number density. If this is number density, That means the total number of charged particles divided by the volume. So then the total charge particles that are over here that we actually can have, that is N times V. So it means V is the volume here. It is not the potential difference. So just to make a difference, we can change this kind of like this. So volume multiplied. So total number of charged particles. So these are the N times the volume is the total number of charged particles that we do have within this volume times the charge of one charged particle, that is the total charge within our this conductor, for an example. And now, if that passed on within the time interval delta t, then we can say that the charge density, charge of the one charge, volume, then divided by the delta t, or for just simplicity, we actually write delta t like this. Now, this volume, what the volume is? Volume is length times cross-sectional area divided by the delta t. So length divided by the delta t, what is it? This is the length over delta t is actually our drift velocity, that the charged particles are drifting within this length L within the time delta t. So now we actually found that our final formula I is equal to the N charge density, then the value of the charge, cross-sectional area of the conductor, and the drift velocity. So in the simple words, that our formula for the drift velocity is equal to the current flowing through the conductor divided by the number density times the charge of one charge times cross-sectional area of the conductor. So this is the formula to calculate the drift velocity. And you can also utilize it to calculate or to find the number density of different conductors. So with this understanding, now our next topic is electrical power. What electrical power is, let's try to understand it. Now we know that the power mechanical definition of the power is the power is equal to a rate of performing work or rate of transfer of energy. So we can say that the power is equal to the energy divided by the time, energy divided by the time. And for this electrical power, then our this energy will be electrical energy. So electrical power is equal to electrical energy divided by the time. What electrical energy is? We understood in our actually the definition of the Ohm's law that the potential difference actually is the electrical energy provided to a unit charge. So then this electrical energy is equal to the charge times potential difference. Now, if we put this value of the electrical energy in this formula, then we can see that the power is equal to charge times potential difference divided by the time. Now, here you can see that the charge over time, what is it? This is current. So now we can see that the power actually the product of current and potential difference. Now, if, for example, we apply here the Ohm's law, that the potential difference V is equal to resistance times I. And now we replace this potential difference in this formula of the power. Then we can see power is equal to current, and then potential difference is resistance times current, or current times resistance. So current times current is current square. So I square times R. This is our power. And using this formula, we can also calculate the dissipated power in the wires, in the coils, in conductors. Now, if, for example, we actually try to eliminate the current instead of the potential difference, then from Ohm's law, we can see that the current is equal to potential difference divided by the resistance. So now our power, you can see what the power will be. The power is equal to current is voltage divided by the resistance times the potential difference voltage again. So potential difference times potential difference, it's a square divided by the R, that is the power. So now here we understand the concept of this power. So you can calculate the electrical power using different formulas that depending on the problem you are addressing. For example, if you have the energy, electrical energy, and the time, so you can calculate the power using this formula. If you are dealing only current and potential difference, then our this formula, that power is equal to current times potential difference. And if you want to calculate the dissipated power, then you will calculate it I square R. So in terms of current and resistance, and in terms of potential difference and resistance, you actually have this formula. So these are four different formulas that you can utilize to calculate electrical power. So this is the concept of the power. So far, we understood the Ohm's law, and then the definition of current, voltage, and the resistance. We also discussed the resistivity briefly because we have already discussed in our previous lecture. And then we also actually in details understand drift velocity, and after that electrical power. So after understanding these basics, now we can move towards the electric circuits, or you can say in simple words that electrical circuits. Let's go there now.